Hi, I'm Bing. Today, I will present my project, Lightweight Open Source Models for Python Unit Test Generation. This project proposes a Python unit test generation framework using lightweight open source large language models, analyzing the performance of different lightweight open source models using different prompt techniques. This presentation comprises 5 parts. First, I will state the motivation behind this project. Next, I will present the research question this study wants to answer. Then, I will describe the methods used in this project, followed by the experimental results. Last but not least, the discussion part reflects this project's achievements. The first motivation is that modern software development relies heavily on automated testing, since the manual testing can be time-consuming, prone to human error, limited in scope, or having low efficiency. Using large language models is a promising approach, as it can automatically generate tests from code or description. However, besides accuracy, test mail is also a problem with these test suites, since the output can have poor design, making the test hard to read or hard to maintain. If understanding how reliable these lightweight public large language models are, we can have efficient test automation, increase software reliability, while still can adopt large language model in offline economical mode. Related to this problem, there are some related work. The first one studies the performance of codecs, showing that combining natural language instruction with code example can improve usability. Nonetheless, its tests on a single model and did not evaluate the structural quality of test mails. The second paper uses ChatGPT for mobile test generation, showing that this model is effective when provided with enough project context. However, it's focused specifically on mobile testing. Part of my project is based on this work, which assess the test suite generated by GPT-4o, Amazon Q developers, and Llama 3.370b. It also investigated test mail, but showed the result only on large models and using simple prompts. Generally speaking, existing work has some of the limitations, including lack of structural or semantic quality, only using one LM or single prompt context, or relied heavily on large public large models. Given this drawback, my project aims to answer 3 questions. Can lightweight open source language models generate practical test suites? What are the impacts of different prompt techniques here, and whether lightweight open source large language models having lots of test mails? My method then includes 4 phases: prompt selection, model selection, model test suites filtering, and evaluation. For the first phase, I use 4 different prompt techniques here. Minimal prompt means using only the function code. Doctrine-based prompt is when I give the description of the function I want to add to the large language model. Instruction in hand prompt is giving instruction for the model on how should the test suite look like. Finally, example augmented prompt is when I feed the example's perfect test suite for the models. This is an example of mini prompt when I ask the model to generate text given the function code directly. This is doctrine-based when I only show the doctrine or description to the models. In this project, I also combined minimal prompt and doctrine-based prompt to see the results. For instruction prompt, you can see that I add the instruction on how should the model build the test suite here, and the formal parts can be minimal or string-based form. I choose 4 different models to test here, belonging to 2 different families and of different sizes, 3 billion and 7 billion parameters. These are among the most popular open source lightweight models for coding. Then, in the third phase, I will extract the Python code and clean the code using Python abstract syntax tree modules. The image on the left is an example of the model output here, where I need to extract the test script from the answers. Finally, based on the filter output, the framework automatically creates test file including the query function and its generated test suites, so that I can measure the performance of these models. For experiments, I use OpenAI human eval data. Like many existing work, I use the prompt for docstring approach and the canonical solution as the function goes here. I ignore all other columns, since the solution here is already correct. If the test suite catch an error, the problem lies in the test suite. I use 4 main evaluation matrices here: syntax correctness, semantic correctness, code coverage, and decimal similar to existing work. Also, this work did not measure the code coverage here, and in my project, I measure all of them. First, I test the performance of minimal and docstring-based form, through simulate approaches. The outputs are generally unusable since you can see that they generate hints only, try to fix bugs, unrelated answers, or some random terminal commands here. That's why I need to have instruction enhanced prompt to tell the model exactly what should they generate, as I mentioned in the methodology section. These 3 tables are for different inputs, like description only, code only, and both description and code as the input for the models. I ask the model to generate exactly 5 tests per problem. Here, the test suite is perfect when it has low syntax error, low semantic error, and achieve 100% coverage. When model tend to perform the best given the same parameters. Queen 7b always have the highest rate of perfect test suites here. When I allow the model to generate as many tests as I want for the test suite, we now see that not most of the time, but always, when models outperform Type-2 here. Even when model with only 3 billion parameters can outperform Type-2 with 7 billion parameters. I observed a similar trend when using prompt with examples, except that when 3B even gets a highest rate of perfect test suites, and this result is achieved through description input. When I look at the output, I found that though Quen 7b tends to have fewer invalid tests and having the high coverage, the errors are distributed quite evenly. That's why it has a lower number of perfect test suite compared to Quen 3b. Also, the Quen 3b performs the best for description since the model is small. Given the description only, this model may focus on the requirement only and not distracted by the code. So that's why they can have like many invalid tests, but still achieve the perfect suite here. The most perfect suite here. For the test mail, I measure the percentage of test mail per file per test mail per file, and number of files, and the rate of files with at least one smell. Quest 7b achieves the best result most of the time. Meanwhile, Sarcoder 7b have lowest rate of files with smell for both coding and coding plus description for the input here. You can see here. But this is just the rate of smell test suites. Sarcoder 2 has some test suites which are very, very short and they have very low coverage. But due to that, can have a lower chances of smell for these short test suites. So this does not reflect thoroughly the performance of Sarcoder 7b. That's why I have this feature. When we look at the actual numbers of smells in total, we can see clearly that Quen 7b always has a few test smell error, the red one, regardless of the smell types, followed by Quen 3b. Meanwhile, Sarcoder had much more test smell here. To conclude, lightweight models can act as an assistant to quickly test the Python function. However, simple prompt like asking the models to generate the test directly does not work at all. I spent a lot of time querying them in different ways and they will struggle to generate the test properly. Then I found out that the lightweight models can only work if we provide the exact instruction for how should they generate the test suite. For highest reliability, from the result from the experiment, we can tell that we should prioritize quencoder over sarcoder 2. Part of my project is based on existing work, but I need to re-implement from scratch due to the lack of available source code on GitHub. To the best of my knowledge, this is the first work for Python test suite generation using lightweight open source large language models. I also publish the code so that anyone can use if they find this project interesting. Thanks for your listening.